So the money multiplier, the concept is laid out right here. More reserves that banks have, the more they're going to lend out. If they have excess reserves, they're going to want to make extra loans if they can. So a larger increase in the reserves will lead to a larger increase in the money supply because of the money multiplier effect. So mathematically, the money multiplier is equal to 1 divided by the reserve requirement. Nice and simple, right? This should also look familiar. You can relate this to the spending multiplier. An additional amount of government spending is going to lead to a larger amount of growth in the economy because of the multiplier effect. It's going to be a finite amount of an increase, though, because at each stage, a certain percentage of the money that's going to the next step in the cycle is being taken out. And that percentage that's being taken out, the marginal propensity to save, which is 1 minus the marginal propensity to consume, 1 divided by that is our multiplier. It's what you get to when you do the infinite series and you solve that mathematically, where you're adding a certain amount with a certain percentage being taken away, and then you're doing it again and again and again, where you have x minus that percent that's being taken out. We're not going to get into the math here, because I want to keep these videos less than 15 minutes, but if you want to go into infinite series and derive this way of doing things yourself, you certainly may. But it does ultimately converge to 1 divided by the percent of that money that's entering into this phase of the process that's being taken out. That percentage is the same each step, in each step of the sequence of income becoming spending becoming income, or in this case, deposits becoming loans becoming deposits. A certain percent has to be held in reserve by law. That's the reserve requirement. If deposits go up, the dollar amount you have to keep in reserve then also must go up by law to remain legally compliant. You want to lend out extra money that you have, but you have to keep some of that extra money to cover your deposits. So at each stage, when extra money is lent out and then gets deposited and new money gets lent out, a certain percent of the money before it gets lent out is kept in the system. So it's all going to come to an end at some point, and it's the same exact math, the same concept that leads us to 1 divided by the percent that's not re-entering the process, the percent that's exiting the system. 1 divided by the marginal propensity to consume, or marginal propensity to save, or in this case, 1 divided by the reserve requirement. And if that reserve requirement is increased, then the money multiplier is then going to decrease. Just like a smaller marginal propensity to consume means a smaller multiplier effect. This is going to become important when we talk about monetary policy and the levers of monetary policy, and why changing the reserve requirements is one of the tools at central banks' disposal that they can use. They don't generally prefer that tool, but they have used it before to increase the money supply or decrease the money supply. They can raise or lower this requirement as one of the things that they do to try to influence economic activity. But we'll get into that again when we get into monetary policy. Right now, we're just going to see how this is going to cause the money supply itself to change. The equation that you're going to use. The change in the money, remember this Greek letter delta triangle, MS stands for money supply here. RR, again, does not stand for railroad. It stands for reserve requirement. The change in the money supply that this multiplier is going to bring us to is going to be equal to the multiplier, 1 divided by the reserve requirement, which, because we're dividing by decimal here, 0.1 if it's 10%, 0.15 if it's 15%, etc., we're going to get a number that is not a decimal, generally. And then we multiply it by the change in reserves. So if a deposit causes the reserve amount to increase, we're going to multiply that increase by the money multiplier to see what the change in the money supply is going to be. So we have an example here. The banking system, this is actually an example not of how deposit will change things, but this is getting back to the thing I cautioned you to keep in mind at the end of the last video, we're assuming banks want to lend the whole thing out. That's not always the case. So we oftentimes talk about the potential increase in the money supply. And it is the upper limit to the increase that can happen in the money supply because, again, banks have to keep a certain amount of it in reserve. So like it or not, they can't increase the money supply by more. And again, they don't consciously do this. It's not a conspiracy thing like in the first video, the expert on Coast to Coast saying that it's this sinister behind the scenes thing where banks are secretly controlling things. It's not quite how it works when banks create money. They don't mean to do it. They just mean to make loans that'll make them some money. I mean, why would they want to increase the money supply? And actually, if they do that and they cause more inflation, they're hurting themselves because they want to keep money, some money in reserve, but all the money kept in reserve is going to lose value. Their bonds are going to lose value. So banks don't tend to really like inflation. Interest rates that are fixed tend to be very vulnerable to inflation. So banks would rather keep the money supply down, but they also need to give out loans, so they're going to increase it. So it is the upper limit to the potential increase. So using these numbers, you have $2 million in deposits. They're holding $600,000 in reserve, and they are required to hold 20% in reserve. 20% of $2 million must be kept in reserve. So which of these four numbers is the right answer to the potential increase to the money supply? Well, one thing that we can do to organize our thinking here is we can put it in the bank balance sheet. So this sets it up. Customer deposits are $2 million. Their reserves are $600,000. We're not really worried about the net worth right now, and what we're saying is these reserves, they're not going to want to buy securities. They're going to want to put it into the form of loans. And of course, the one other important number is the 20%. Now, this is a PowerPoint slide. We can't work with it as well, but fortunately, I have this handy thing available. But now let's build another couple of things. Let's build the Money Multiplier, and then we can call this the potential increase in money supply, or I will just call it money supply increase. Better yet, money supply change. It's the potential change, but we're assuming they're going to be loaned up. And then, again, how to do formulas in Excel. Push the equal sign, telling Excel that you want to create a mathematical rule for them to follow. The money multiplier is equal to 1 divided by whatever this reserve requirement is going to be. It's a blank cell right now, but J3 is telling it that when we put a value in there, it's division by 0. Now, you can't do it. Exclamation point. Even Excel gets mad when you divide by 0. Your math teacher gets mad. You got to throw out Riemann spheres, as I discussed in one of the classes, to defend yourself from the angry math instructor. You can't divide by 0, doggone it, but you can in a Riemann sphere. Can't touch me now. Excel doesn't hear you say that, so it'll give you the exclamation point. But as soon as we put a value in here, it's going to tell us what the money multiplier is. In fact, we can do that right now. The reserve requirement that we're working with is 20%, or 0.2. What do you know? We have a money multiplier of 5. The equation was solved for us. So the money supply change, we're going to have to put some more numbers in here to generate everything, given the equations we already have for excess reserves, etc. But the money supply change is going to be based on the excess reserves. Remember that formula that we had? We can go back to PowerPoint here. This formula right here, the multiplier multiplied by the change in reserves, well, that can also be the excess reserve amount that we're going to be working with. So it's going to be our money multiplier. So tell Excel to solve a math problem. It's going to be equal to the value in that cell, J9, the money multiplier. It uses the asterisk to multiply things. It's going to be multiplied by the excess reserve amount. And that's going to give us our new change. Now, it's 0 right now, but that's because we didn't put anything in here. So the initial number of deposits, recall, was, in the example, they had 2 million sitting in there and 600,000 in reserve. So let's put 2 million. That should be 2 million, right? 2 million in deposits. That based on our formulas, changes everything. They need to have a certain amount of money in reserve, though. And in this case, it's 600,000. And look at that. This was in that multiple choice answer. 1 million is the correct answer. It actually says that down here. The correct answer is D right there. And we found it in Excel, which means we set it all up right. This again, C10 minus E3, it's giving us a bunch of, well, we can, there, minus 1,400 because we don't have anything here in loans and securities. We could put money in there, but that's not the purpose of this assignment. So we're not worried about net worth. We're just looking at how much can the money supply potentially increase given 2 million in deposits and 600,000 in reserve. We have excess reserves because they only need 400,000 in reserve, and they have 600,000. We told Excel here, subtract C9 by J5, subtract C9 by J5 to get the excess reserves of 200,000. They can lend all that out, and if they do, the money multiplier is going to be used to bring that number to 1 million. So we can play around with a number of different things. We can see the same banking system. What would happen if the Federal Reserve decided we want to contract the money supply? We got too much cash out there, or the economy's overheating. We want to fight inflation. We don't want to raise interest rates. We'll get into monetary policy. That's one of the things they can do. Instead, let's tell banks to hang on to a little extra money. Well, look at what happens. Our money multiplier changes to a smaller number, 3.333. And money supply didn't change all of a sudden. Oh, that's because there are no excess reserves. Look at that. Because the required reserves are now 600,000. I didn't work these numbers out beforehand, but it looks like it would if I did. If they change that reserve requirement, money supply all of a sudden is going to remain fixed. So let's have some fun here because this is real fun. Let's change it. Let's say this is never going to happen. Federal Reserve would never tell banks to hold on to half of customer deposits. A lot of banks would say, I can't run my business anymore. We're going out of business. But now we are going to see a contraction in the money supply. The Federal Reserve has succeeded at reducing the money supply as a safeguard against inflation. What happens now is when banks aren't going to go and collect money out of the system and destroy it or anything, but this is the decrease in the money supply that would happen as banks pull money out of the system and keep it in. We're going to see a factor of a decrease like this. This is kind of an oversimplification of what would really happen, but you can see how increasing the reserve requirement contracts the money supply. Meanwhile, we change it from 20% to 10%. Well, now we have a change in the money supply of 400,000. Again, what Excel is doing, we already told it to calculate excess reserves. It's taking that excess reserve amount and it's multiplying this cell, J7, by the money multiplier. And it's just nice, neat, simple math like that to get the new amount. And the money multiplier itself is simply being constructed by taking 1 divided by whatever our reserve requirement is. So you can play around with this from several different angles. Let's reset it back to the example from the PowerPoints. But now let's say that an additional $1 million gets deposited into the banking system. We actually now have to change this by 1 million because it instantly goes into reserve. That deposit is going to lead to a money supply change of 5 million. 1 million put into this banking system will cause $5 million of extra money to go out there. And because it generally goes out there because loans are approved to do economically productive things, that really does turn into a $5 million bit of growth that happens in the economy. Once this, it's not instantaneous like on an Excel spreadsheet, but once all this carries through, then that's how much will be added to the economy. And this is why banks will do things like lowering the interest rate to try to increase the money supply when the economy is weak and needs a jolt. Again, we'll get into it in the monetary policy portion of things when we talk about the Federal Reserve, but this is kind of where the math comes from. But that's for